Aw, look at the cute little ladybug. Oh, wait, a ladybug. Aw, nice. Ladies and gentlemen, what's up? Welcome to Section 7 of Chapter 10, and here's what we're going to talk about. Two different videos I'm going to make. Well, both of these should be pretty short, but here's the first essential question we're going to talk about. How do you find the points of intersection of a circle and a line? Oh yeah, boy. And I'm going to do this one graphically, and the other video I'll do is algebraically. So we're going to graph these circles and lines and find the points of intersection. So here is the first question. If you didn't write that essential question in your notes, you need to. First example we're going to do is this. Find the points of intersection of the graphs of these two things. Here is a circle. Ooh, x squared plus y squared equals 13. And this is regular old linear equation, y equals mx plus b. So remember, lovely, this thing right here, again, is a circle centered at the origin. We talked about that. Where it is x squared, the generic standard form of a circle centered at the origin, where it was r squared. Remember, all we had to do back in the day was figure out what the radius was, and that helped us draw the circle. And then this right here is, of course, just mx plus b. So we just need to use that idea from way back in Algebra 1 and what we talked about this year for slope-intercept form to graph that equation. And that guy right there. So that is the deal. So we're going to put this on a coordinate plane and we're going to graph this circle. Now this isn't exactly accurate. I'm just showing you an example. We're going to graph the circle first. And then we're going to find out whatever the equation of this line is and graph the equation of the line. And then, ladies and gentlemen, wherever these two things intersect, where the line intersects the circle one spot and where the line intersects the circle at the other spot, that is going to be our answer. Happy day. Oh, what a smiley face. Ooh, he's looking at the ladybug. Hello, ladybug. How are you? Alright, here we go. Let's get to this example. So what's the deal? Well, let's go over here and do this example. How do I do this goofy thing right here? Well, I gotta graph this thing right there. The standard form of the equation of a circle centered at the origin. So right there is the origin. What I have to do is I have to find, that's right, the radius length. How do I find that? Well, remember, back to the slide I just showed you, it's x squared plus y squared equals r squared is the the standard form of the equation of a circle centered at the origin. 13, ladies and gentlemen, is not my radius. How do we find it? That's right. We have to square root that guy to find the radius length. Well, the square root of 13 is somewhere around approximately, I think, 3.6. So, if I put a dot at 3.6 up here, I put a dot over here at 3.6 right there, I put it over here at 3.6 right here, and I put it over here, whatever. So there's your 4 dots. And if I draw my little circle, there it goes. So I'm going to dot you a little off, whatever. So there is the circle centered at the origin with a radius that is 3.6-ish, somewhere around there, approximately 3.6 away. Lovely. So now what do I have to do? Well, let's change colors, if I can do that. Oh yeah, let's make it blue. So now I have to graph the equation y equals x plus 1. Well, here's what I know. It's a straight line, whether it's going up, down, left, or right, doesn't matter. But in this case, I know the slope is positive 1. So therefore, I know I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to start my y-intercept there of positive 1. So at positive 1 right there is where I'm starting. And I go up 1 over 1, another dot. 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 And you can see it's just creating this straight line right there. So when I graph that straight line, there it goes. Wait, Mater, what's the question asking us again? It's asking you for the points of intersection of the circle and the line. Oh, lovely. So all this is really wonderful, but let me get rid of this. Can I get rid of it? I don't know. We'll see. Bam. So here is the answer. It's asking for that point right there, and it's asking for that point right there. Wonderful. So you have to graph the circle, graph the line, and my answers would be this. The answers are two things. One is 2, 3 is this first point right there. And then this second point right there, that guy is -3, -2. So there my two, or are my two, answers to the question. How cool was that? Let's do another example. And I hope you wrote that in your notes. If you didn't, that's what I'm checking for if I check homework. That example right there. And also this example. Don't shortchange yourself. Go to this example too. So, find the points of intersection of the graphs x squared plus y squared equals 25 and the linear equation 2x minus 5. Oh boy. Okay, well, let's do the circle first. It is centered at the origin, and my radius, oh, is it 25? Yep. Hey, it's 25. Wait, no it's not. Not because the graph isn't that big, because remember, I have to take the square root of that thing to make it work. So my radius length, the r, the radius length is 5. So at 5 up here, at 5 over here, at negative 5 over here, whoa, what a weird dot, at 5 right there, lovely. So there is my circle, wee-hoo, wonderful. The radius is 5, that is excellent. Now I have to just go over here, let me change colors, let's go to purple, why not? So I have to now graph this thing. It doesn't really look that much different color, whatever. So I have to start at negative 5. That is my y-intercept, so at negative 5 right here. Lovely. And then I got to use my slope, which is 2. So it's a 2 rise over 1 run. That's the slope, up 2 over 1. So I go up 2 over 1, there's a dot. 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 So when I graph the line, woo, there she goes. Wait, what's the answer to the question? The answer to the question is, where does this line and the circle intersect? Well, let me erase this, if I can. Why won't it let me do it? I don't know. I have no idea. Why is it not doing it? Here we go. Okay, so here's the point. That point right there is my first answer. So at 4, 3, there's one of my points of intersection. And my other point of intersection happens to be down here at 0, negative 5. Awesome! So there are two simple examples, guys, of how to find the points of intersection of graphs of a circle centered at the origin and a linear equation, just a straight line. So that's how you do it graphically. The next video lesson will be on how you do this algebraically through a little thing called substitution. I didn't hear that. Substitution! What up? We'll talk to you later. Peace out.